Hello all, welcome to BISP Today in PBCS we are going to see scenario dimension, version dimension, then dynamic time series in period dimension, and alternative hierarchy members. So let's start with scenario dimension. Let us go to the application. So through navigator I've gone into dimensions, and here I'm selecting the scenario dimension. So these are all the members created. Now a scenario dimension, this represents a set of data such as actual or plan, budgeted or forecast. For example, the actual scenario can contain data from a general ledger reflecting past and current business operations. On the other hand, the plan scenario can contain data that reflects the targeted business operations. Now when I click on edit on one of the members of scenario dimension, here now we will see the properties which is there. So first you can see is the name of the member, then the alias table which is generally default. Then here we can provide alias also, like the name is actual, we can again write the actual over here, like which would be alias. Then we have to give the start year. So this is first financial year defined in the application. So this is FY15. So when we configure the application, we have there we give the start year and the end year. Okay, so this the whole list of the years, it comes in this drop down, and we may select from here. Ideally it is the first financial year as defined in the application. Then start period, this is the first base time period which is also defined in the application. So we have chosen our fiscal year which starts from January, so this is the start period. Now the end year, this is the last financial year defined in the application. Now you can see this is actual scenario. So here I will be having data for the actual years, for the years which is historical. All those data will come over here. So here start period I am keeping it as FY15, and end period end year I am making it as FY24. Since after this FY24, the data now, I mean now if we are creating uh, the end year on today's date, so for the actual scenario FY24 will be actual, and FY25 would be either budget or plan or forecast, since from FY25. Now in the next year, the end year would be FY25 for the actual scenario, and the years coming after it will go into budget scenario, or maybe plan or forecast. So this basically depends from one organization to another. Then end period is the last base time period. So this is September going on. I'll take for actual September over here. Then this is include beginning balance as time period. This has been enabled. This is basically true or false or an integer. So non-zero will be true and zero will be false. Then this is enabled for approvals. So if I enable this scenario will be there in the approval. This scenario, it will get included in the approval unit. So to check this approvals, we can go into the manage approvals, and from there in the approval assignment unit, when you will see this particular cube, you will find actual scenario over there, that I will show you after we finish this whole properties over here. Now next is this exchange rate table. So if any exchange rate is defined in the application, it will be provided here in the drop down. So right now we haven't provided any exchange rate, so that's why it is not coming here. Okay, now next is hierarchy type. This is either stored or dynamic. So the hierarchy type for a dimension is this is basically set at the top node members of each dimension, and then all descendants inherit the parent's hierarchy type. First is here you can see not set, that means the hierarchy type is not, we are not setting. Next is the stored. This is the default type, and this aggregates members according to the outline structure. And this is a fast hierarchy type because it aggregates storage databases and which are optimized for aggregation. Next is dynamic hierarchy. Calculates members and formulas instead of aggregating them. So they will have formulas. So basically this dimension hierarchy, this defines the structural and mathematical relationships between members in an application. So here we will take stored because we want this to aggregate and not to calculate member formulas over here. Next is data storage. This I've already explained you in the last session. It will be store or dynamic calc store or the dynamic calc or never share or label only. So we have selected here store. Then we have already discussed the rest of the properties. Then next is version scenario. So version is used to compare different versions of similar data, like budget differences from the current period to previous year. So there will be two versions, the current year one and the previous year. To explain versions, I will describe much better in a case scenario. So this manufacturing company, like this is global retail. Now global retail sets up the version dimension in their PBCS model to manage and analyze different versions of their financial plans. See the following versions they have, and I will tell you how will this version help the manufacturing unit. First is the original budget. Second is revised budget. Third is quarterly forecast. And lastly is end of year projection. So here this manufacturing unit has 4 versions in their PBCS model. Okay, so the first one, original budget. So this global retail manufacturing, this begins with the original budget plan. which is based on the projections and assumptions. This version will include anticipated revenues, expenses, and investment for the upcoming year. Next version global retail has is of revised budget. So this is I told you that the global retail started with original budget at the starting of the business. Then in the mid-year, it revisits their budget due to unexpected changes in market conditions and supplier cost. They updated their budget to reflect new cost structures, revised revenue forecast, and adjusted investment plans. So this updated version, they have revised their original budget in the mid-year. So now this version is being used, which is revised budget. Then at the end of first quarter, global retail creates a quarterly forecast to track the performance and adjust plans for the remaining quarters. This version includes actual performance data for quarter 1 and revised projections for quarter 2, quarter 3 and quarter 4. Then as the year progresses, global retail prepares an end of year projection to estimate final outcomes based on current trends, market conditions and performance. So these projections basically help in preparing for year-end financial reporting and strategic planning. So this is how there are 4 versions created, and this enabled global retail to manage and analyze multiple versions of their financial plans. So by setting up different versions, they can track changes, compare scenarios, and make informed decisions. These are various versions created over here. Which is based on the business requirement, as I just explained in the case scenario. Now here the first version you will find is sandboxes. If you remember, when we configured the application, they were in the details, we were given the option to choose to enable sandboxes. So this is enabled at the time of configuration, and basically this is used so that the users can keep their work private. As there are various users and they develop different plans. So that if they want it to, keep them, if they do not want other users to interfere in those planning or interfere in the numbers that they have given for the estimates, so this data sandboxes helps in that time. Users may want to privately experiment with various outcomes in a sandbox, without having others see their numbers until they have completed their analysis. So when they are ready with their numbers, then they publish the data in the sandbox. Then here, this is next is this working version. So let's go into this edit, and let's edit it and see the properties over here. So here there is again name, alias table, alias. Then you can see here there is type. So first is standard bottom up. This means values are entered at the lowest member level, and it is aggregated up. So this bottom up version, here you enter data into bottom level members, and parent level members are only for they are basically display only, and they will not allow data entry over there. Parent members values are aggregated from bottom level members. Next is standard target. So here the values are entered from the parent level down. So here you can enter data for members at any level in the hierarchy. You can use business rules to distribute values from parent members to their descendants. This is used to set high level targets for the plan. Next is enable for approvals and enable sandboxes. This too we have already seen in the scenario. Then I have told you what is hierarchy type, which is stored and dynamic. This we have discussed. Then the data storage, and rest all the properties we have already discussed in the last session. Next is the period dimension. Here we have beginning balance, then year total, which comprises of quarter 1. When we drill it down, we have January, February, March. Similarly, quarter 2, quarter 3 and quarter 4. As such, here we do not have view dimension. So in place of that, we can use dynamic time series, that is DTS members, which is used to create reports that show period to date data, such as quarter to date expenses. This YTD, then this QTD, these are all DTS members. and basically they are created automatically during application creation and can be used with members of the period dimension. And to set up DTS, you have to enable a predefined DTS members and associate it with the generation number. For example, to calculate quarter to date values, you can enable the QTT members. The other DTS members are HTD, which is history to date, YTD, you can see over here, this is year to date, then also STD, which is season to date, then PTD is period to date, here there is QTD, this is quarter to date, MTD is month to date, then you can have week to date and day to date. Next topic is attribute dimensions. So basically, attribute dimensions are they describe the characteristics of data. They are used to analyze data based on the attributes and qualities of dimension member. Then only one attribute from a given attribute dimension can be associated with one member. For example, if we have employee dimension, then it can be categorized on the basis of maybe gender, like male or female. So here if I see this is one of the custom dimensions product. I have opened it. This is P_100 product X. Now to create a custom dimension, I have gone into dimension, and there I'm creating a custom dimension for product. So I have open product dimension over here, and then when we click here on the custom attributes, so here you can see one of the custom attributes is already created, which is product type. To create another one, we'll click on this icon, and here we'll provide the name, data type. So we will create one attribute, which is stock keeping unit. Data type is there you have the option to choose between text, date, boolean or numeric. So I'm making it as numeric over here, and I will save this. So this is one of the attributes that we have created. Similarly, we can if we want some more attribute to define the characteristic of the data, we can create by the same method. So this is a product, and one I'm creating is release date. So this is the date when the product was launched, and this I will make it as date and save this. So this I have created two attributes. Further, if I want to create uh, the descendants, so here I've chosen this, and I'm creating descendants of stock keeping unit. I have given two numerical units. So we have created two attributes. Further, in the attribute that we have created two descendants in the attribute that we have created. So now close this. It does not have a valid member. I'm right now creating the two. This I've created. Under product type, we have created the two descendants. This is software and hardware. So you can see here one we have already created. This is product type attribute, and I had created two more, but it is not accepting. There are not valid members. So let's make it as product category. And it has taken that, and now here we'll refresh the database. So this is product X, and we will go and see how the attribute values are enabled over here. We have created product type and product category. So this is the product type. We have attached this attribute value to this product member, and save this and again refresh the database. Okay, now so you can see here we have created one attribute value, and we have created one attribute dimension over there, and that the custom attribute that we have created, this comes here in this available attribute value list, and we have to, whichever is required, we have to attach it to the member. Next is user defined attributes, which is UDAs. So this UDA, it can be used within calculated scripts, member formulas and forms. An attribute can be created using text, and here multiple UDAs can be associated with users, which is unlike from the custom attributes that we have created. So to create UDA, go on this edit, select the member, go on edit, and here you will find UDA. Here click on this icon, plus icon, and you can create a number of multiple UDAs, and this can be associated with the users. And here it basically doesn't have any hierarchy. So earlier I was telling in the case scenario of global retail, where it has created 4 versions. So the same manufacturing unit, to better analyze their products, they have decided to define several UDAs for this product dimension. So the two we were trying to create in the attributes, but since they were not a valid data for that, so it was basically release date and stock keeping unit. And there are many others that they have created. First I've taken release date. Here I've created one UDA. Then it could be next is product life cycle. Next is the channel, to differentiate various sales channels like online or maybe retail or wholesale. So I've created 3 of them. And to select this particular, you will get this list of UDA on the left hand side, and to associate it you have to select it and bring it down over here. Unlike attributes, you can select more than one UDA for a particular member. So here you see the attribute value, we cannot select more than one, but for the UDA, if you see, I've created here and selected 2 of these UDAs for this product P_100. Okay, next is shared members, and let me refresh the database because we have added UTAs over here. So shared member is a copy of an existing member in the hierarchy. They are useful because they save space and processing time in database. Some points to be remembered in when we create shared members. First, the base member should be created first. The existence of base member is required. Then we can create multiple shared members for that particular base member, and then it must be at the lowest level in the hierarchy and it cannot have children. So this is P_100, you see here. Then this is another hierarchy. So I am telling you how to create shared members. Let's suppose this product X is there in computer equipment. So in some of the elements of product X also belong to computer accessories, to this hierarchy. Then we actually want to have the same member over here. So to create one, we have to create P_100, which is a base member, and we are creating a shared member of this P_100. This data storage property here will be shared. It says the properties will be overwritten with the base members properties on choosing shared data storage. So what it means is that the property of this P_100, a shared member, would be similar to the base member, which is P_100. So we'll click on OK. and save this. So you see we have created a shared member here, which is p_100 shared. This is p_100. This is the base member, and this has been copied over to here. And this this shared member, it can store data, and the values are stored with the base members. So that's it for today. If you have any queries, you may write into us at bispsolutions.com. Thank you.
Departments, and under this is a no department 000, and when you click here on 100, this is a resources entity. So under that, when you expand this, we have some of the more entities together. Okay, let me just make it clear. So 110 is for facilities resources, 111 is for west region resources, and so on. Okay, now we'll just move towards the